Hey Theo, I need some help. Oh my gosh, are hydrogen bonds the same thing as strong dipole-dipole interactions?
Well, that's a very good question. Thank you, Tina, off camera. So the answer is kind of. And at a HSC level, we do generally treat a hydrogen bond as a strong type of dipole-dipole interaction, but there's a bit more to the story than that. Formally, a dipole-dipole interaction occurs between a very polarized hydrogen bonded to something else, so something very electronegative, that's on one molecule, and on the other molecule, we have to have a very electronegative element which has some lone pairs. Now, that's the formal definition. How do we bring that together at a HSC definition? Well, the best way we can bring it together at HSC is we can say we have a hydrogen which is bonded to one of our most electronegative elements. So that's our nitrogen, our oxygen, or our fluorine. Hydrogen, nitrogen, hydrogen, oxygen, hydrogen, fluorine bond on one molecule. On the other molecule, we need that rich source of electrons. So we need a nitrogen with a lone pair, an oxygen with a lone pair, or a fluorine with a lone pair. We call this first category a hydrogen bond donor, and the bottom category a hydrogen bond acceptor. Let's try and put that into practice. Let's have a look at our first case, which is between two water molecules. Well, water, we notice, has a HO bond, and it also has a lone pair with oxygens on it. So if we have a look at this bond, we can classify this one in green as our H bond donor, right, and our green oxygen over here as a hydrogen bond acceptor. So we will indeed get a hydrogen bond between this hydrogen and its oxygen over here. Hydrogen bond. Let's have a look at the case B. We also have hydrogens on both compounds, but in the case between water and methane, although we have a hydrogen bond donor, the OH bond, we actually have no side of hydrogen bond acceptor, right, on this second molecule. And the reason for that is that all of our CH bonds are non-polar. There's not a big difference in electronegativity, so it's not a polarized bond. The final case is the most interesting one, and this is where a crude definition of hydrogen bonds you might get tripped up on. In our final case, we have water and we have acetone, or propan-2-O. What we notice is that propan-2-O has a site of hydrogen bond acceptor. It has this C double bond O, this carbonyl group, which has a lot of electron density around those oxygen due to those lone pairs. And on our second molecule, we do indeed have our OH bond over here. So on our water molecule, we have a hydrogen bond donor. On our acetone, we have a hydrogen bond acceptor, and we can indeed get a hydrogen bond between these two compounds. If we just crudely looked for hydrogens bonded to oxygens, nitrogens, and fluorines on both compounds, the answer we'd retrieve that is no. So actually, at a HSC level, the best conceptualization of this we can give is between hydrogen bond donors and hydrogen bond acceptors.
Thank you so much. That helps so much.